Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all. Okay, so for today I will show you a video for our lab number 4, which is named as industrial motor control. Okay, so in this lab what we do is we are trying to design a schematic control diagram, okay, for a 3-phase motor. Okay, so as you know, this is a 3-phase squirrel cage start motor. Okay, and these are the ratings: 100 watt, and it operates on 415 volt. Okay, the rating current is 1.3 amp, and the speed is 1420 rpm. Note that these ratings are actually when it is already on load, okay, at full load. Okay, while what we are doing in this experiment is running with no load, so the current value that we may read from the meter is much lower, okay, than the rating current. So in the 3-phase motor here, as you can see, the connections, there are actually 6 terminals. Okay, 6 terminals. As you can see, it is marked by U1, V1, W1, and V2, U2, and W2. Okay, so we are going to connect this in either star connection or delta connection, which I'm going to show you later. Okay, now we go to the other components that we will be using in the circuit. So first one we have this isolator switch. Okay, this is the main isolating part, where it's going to isolate from the 3-phase supply, okay, out of the load. Okay, so secondly we have fuses. Okay, these are protection fuse. Okay, so these fuses will protect the circuitry and the motor should there be any overcurrent. Okay, so when there is overcurrent, there will be blow. The circuit will, the fuse will be blown. And then we have this 3 push finger pressure switch. Okay, finger pressure switch means you can push, and when you release, the spring will return it back to the normal. So it may have a slight contact, okay, a momentary contact when you press, and when you release, it will disconnect back. But we have method to make sure that it is still in contact, which we are going to do here. Is called as a latching method. Okay, so this one is a contactor, magnetic contactor. So the purpose of this contactor is to connect the circuit, connect and disconnect the circuit. As you can see, the contact, the main contact inside this contactor, okay, will handle the voltage, the line voltage of 415 volt. So the contact point must be very good. Okay, must be normally made of metals. Okay, and must be of very durable material. Okay, so the contact will contact and disconnect for each 3 lines, okay, in the 3-phase circuit. Okay, so here we have actually 3 contactors. Okay, in the experiment we'll be using this, we name it as KM1, and later in the next part of the experiment is KM2. Okay, so this contactor also have the part which is the main contact, and the ones that activates it is called the coil. Okay, even though you will see it in this schematic diagrams here is separated, but actually it's all built inside. Okay, but we have internally the wiring is wired through the contact, where you can purchase it in the electrical store. Okay, other than that, we also have the auxiliary contacts which are related with this contact. So what will happen is actually when this contact coil, okay, is activated or energized, okay, so whatever auxiliary contact which is normally closed like this one will open, and the ones with normally open will close. Okay, and when it is energized, the main contacts will also close. Okay, but when it is disenergized, okay, in case of switching off, the main contact will back again open, such that to break the circuit. Okay, so other than the contactors, the finger pressure switch, and we also have this is the thermal overload relay. Okay, but because we have a problem with this device, so we won't be using this thermal overload relay. Is also very important because to break the circuit when it sends an overcurrent, so the overcurrent will cause the wires to heat up until a certain point where it will be disconnected using the heat sensing element. Okay, but this for this experiment will not be connecting to this device. Another important thing is the timer. Okay, so this is a timer. So this timer, you can use it to activate the circuit for a period of time before switching to another schema. Okay, means that if you want to, after switch on, after several seconds, you want it either to switch from star to delta, or you want it to automatically off, you can use the timer. So the timer only controls the control circuit part. Okay, we also have this coil to control the timer. Okay, so and we also have the normally close. Okay, for switching. Okay, normally close and the normally open. Okay, so in this timer, when it is activated, the coil is activated, the normally closed will open, okay, and the normally open ones will be closing. Okay, so we will be also using these meters. Okay, so this meter is equivalent to the multimeter. So, but we have the one that attached in the bench, this AC meter, to measure voltage and currents, where we, at various points, it may be useful for us to measure. So now we are back again. So here I will show you the schematic connections. This is a relay diagram. Okay, one comprising two parts. One is the power connections, where we have the three lines. Okay, this first one, L1, L2, and L3, is the three main line here. L1, L2, and L3. And then we also have the neutral line here, this neutral line, because in Malaysia we are using, for the three-phase system, we are using 4 wires. Okay, 3 are the three-phase of the voltage, and the other one is the neutral lines. Okay, so we'll be using line 1, line 2, line 3, and the neutral lines. First one, after the isolating switch, we have the fuses. So we are going to wire through the fuses. Okay, so okay, line 1, line 2, and line 3. Okay, you can actually, alternatively, you can directly wires. Line 1, line 2, line 3. Okay, so the neutral okay, you can connect to the next point for the neutral. Okay, so after through the fuses, you'll be connecting the from line 1, so line 2, and line 3. Okay, so we complete part for the first part here for the power lines after the fuse. Okay, then actually we have one branch to the control part, which will go through the push buttons. Okay, but we go straight, okay, to the contact points. Okay, we'll be using this contactor. So as you can see here, line 1, line 2 and line 3 and also the neutral are already connected to this part. Okay, so we'll be not using this part, so we connect, but we just leave it disconnected. Okay, but we'll be using this KM1 contactor. So as you can see, line 1, line 2 and line 3 and the neutral is already here. So line 1, line 2, line 3 is now it's normally open for the main contactor. Okay, so now means this connection until here is already validated. So now it's normally open for the main contact, and after that we'll go straight to the motor. Okay, so we'll connect straight to the first 3 terminal of the motor. So this number 2 here will be corresponding to the U1. Okay, so number 4 here, which is line 2, will be corresponding to the V1. And number 6 here, corresponding to the line 3, is going to connect to W1. Okay, so we connect 3 terminal first. We have another 3 terminal. Okay, so we have completed the part where we connect the power lines. Now what is left is the control lines. Okay, as you can see here, you take one phase from L1, okay, and go through the components, and then it will finish at the neutral line. Okay, so first part here from line 1 is to off button. Okay, so from line 1 to the off button, and make sure that it is normally closed. So after off button, straight to the on button, off button, straight to the on button, which is normally open for this part. So after on button, straight to the contactor coil. So contactor after the on button, straight to the contactor coil, which is KM1 contactor coil in A1. So after A2 here, we are going to connect an auxiliary switch for the timer, okay, which is in this normally closed. So after the coil, contactor coil, okay, so straight to the auxiliary, normally closed for the timer. Okay, and after that is back to the neutral. So after this point, back to the neutral. So you can take any neutral, okay, but I think we just select one point to make it easier for you to see. Okay, so now we complete the first ladder. Notice that this part is also called as relay diagram or also ladder diagram. So it has some similarities. So right now we have completed the first the power lines and the first run of the control line. So now we are going to the second run of the control line. So first we take parallel from the on button to the auxiliary contact of normally open KM1. So we can select here this 43. So we parallel with this SB3 normally open. Okay, so we take the parallel. Okay, so after we take the parallel, that means we have completed this part. So from these points after KM1, we will take to the coil of TM of the timer. Okay, so that means we make one long one. So this I think we take number 44. So 44 to the coil. Okay, number 44 to the coil, and then from the coil back to the neutral. So from the coil back to the neutral. Okay, so pause. Okay, now we're back again. So right now we have completed all the power connections and the control connections. Okay, where in this circuit, okay, what we are going to do is we are going to switch it on. So what will happen is we will press on this button and the line will connect power through this controller. Okay. Notice that initially there are no connections between line and the motor. They are all initially by default open. Okay, so we have one line here going to the control. So this is off, means the switch button off initially normally is closed. So the current will follow through, and when you press the switch on here, okay, this will complete the circuit, the first line, and the KM coil will be energized. Okay, so KM coil will be energized, and this is normally closed, so it will complete until the neutral. So when KM1 is energized, okay, this KM1 auxiliary contact will close. Okay, because it is normally open, so it will close. So when it is closed, even though you release your finger from the switch on button, there will be a current through this KM1, okay, through this coil continuously, and another one pass to the TM1. So when TM1 receives this current, this coil will activate the timer. So as I have set that we have around, we can set the timer here. This particular is from 0 to maximum 10 seconds. So I've set here to 4 seconds. Okay. So when the coil is activated, it will start counting until 4 seconds. Okay. When it has reached 4 seconds, the TM1 normally closed auxiliary for the timer will open. Okay, so when this open, the circuit will break. Okay, because and also the KM1 here will be de-energized. So when KM1 de-energized, this main contact will open back again. So it will stop the motor. Okay, so let us see whether what we have been saying is correct or not. Before that, okay, like I said, for the motor, three-phase motor, normally we have 6 ports connections. You have to connect in star or delta. So we have connected 3 ports. So what is left is U2, V2, and W2. Okay, so now we see the diagrams for the star and delta connections. Okay, so you notice that the L1 we connected already to U1, L2 to V1, and L3 to W1. So the U2, V2, and W2, if we connect it to become a common point, so this will ensemble the shape of the star connection. Okay, so this is what we are going to do. So for the first experiment here, we are going to connect as a star connection. Okay, so we just short all the points. Thus, this become the neutral point for the load. Okay, so we switch on the isolator. Okay, after we make sure that we want to have 4 seconds delay. So when we switch on, the motor will turn. Okay, and after you see the timer is already activated. After 4 seconds, it will break the circuit of MC of the motor. Okay, so after we test run just now the connections, and we have proven that it's runs for 10 seconds. Okay, we also want to measure some parameters about the motor. So what we are concerned is the line voltage and phase voltage for the star connection, and also line voltage and phase voltage for the delta connection. So, and also line current and the phase current. Okay, so for now we are going to measure the phase voltage. Okay, sorry, the line voltage first. So line voltage, as I teach you in the lecture, it is between line to line. So between line 1 to line 2, or line 2 to line 3, or line 1 to line 3. So if we measure between line 1 to line 2, so this is also called line voltage. So this also means that we are measuring from point U1 to V1. Okay, so we have a bench meter here. So okay, this is a AC meter. So from U1 to V1. Okay, so from here, switch on. Okay, and we see how much is the line voltage. Okay, okay, 420, yeah, so around 420. Okay, so actually the voltage gradually increase. Okay, but by the time it want to increase to maximum, the timer setting already set. So we may have to increase the timer setting, maybe around 6 or 8 seconds. Okay. Now we want to measure the currents. Okay. So for the line currents, what we are measuring is we must have a true current. For example, we have from line 1, so we must break the circuit. Okay, put the ammeter is between line 1 to the U1. Okay, so you put the break the circuit. So from the line 1 here, okay, straight to the input of the current. Okay, and then the output from the ammeter to the U1. Okay, so switch on. So measure. Okay, it's around 0.164 amps. Okay, so now we have finished measuring the line voltage and the line current. So these are with respect to the star connections. For delta connections, okay, from the phase voltage you measure from W1 to W2. So I'm not going to show you here, as I think you are now capable to connect. So what is important for the phase voltage is between W1 to W2, or U1 to the U2, or V1 to V2. So when you are measuring the phase voltage, you will get another value, okay, which I taught you in class, okay. And then for the line currents, for the phase current, as you can see for the star connection, the phase current and the line current is the same, so the methodology is also the same, okay. So now I leave for you for the delta connection. You have to test the delta connection. First, you have to connect. For the delta connection, as you can see, this already made for you. So you just follow this diagram for the delta connection for the motor before you run it, test run. And after that, what is required for you is measure for the line voltage, line current, phase voltage, and phase current for the delta connection. Okay, so now also between the star and delta, you have to run both. Okay, maybe you have to increase the setting to around 8 seconds so that you can have ample time to read the meters before it is automatically switched off. And what is also required for you is to compare when it is running. You take a RPM meter, measure what is the reading. Okay, so you have to compare between the star connection and the delta connection for the motor. Is it any difference in the speed, where we will discuss the difference in the discussion. Okay, so I think this is part 1 of the experiment that you are going to do, and we have part 2. This part 2 will be some modification. So this one I leave it to you to follow the diagram in the lab module. So you have to do it by yourself. We are going to do automatically forward and reverse motor. Okay, thank you.